Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating discussion about the Rock compiler's ambitious rewrite from Rust to Zig. It's a big move, and there's a lot to unpack. Exciting stuff!
Absolutely. I'm particularly intrigued by the decision to rewrite rather than incrementally improve. It seems like a huge undertaking, especially for a compiler. What were the primary drivers behind this decision?
Yeah, it's a massive project, but the core reason boils down to this. They were already planning to rewrite nearly every component of the 300,000-line Rust compiler anyway, for various reasons. Things like improving error tolerance in the parser, upgrading the formatter, and overhauling the canonicalization process. It was a cascade of necessary changes.
I see. So it wasn't just a whim. It was a matter of addressing accumulated technical debt and architectural limitations. But why Zig? Rust has a strong reputation for compiler development.
That's a great question. While Rust's memory safety is a huge plus, in this specific case, it wasn't the deciding factor. The main reason is compile times. Rust's compile times, especially for a project of this scale, were a major bottleneck, impacting both productivity and developer morale. Zig, on the other hand, boasts significantly faster compile times.
That makes sense. A faster feedback loop is invaluable during development. It's not just about the total time, it's about the iterative process. But beyond speed, were there other factors influencing the choice of Zig?
Absolutely. Zig's approach to memory management, with its explicit allocator passing, aligns well with Rock's existing practices. Plus, Zig offers features like multi-array list and better support for structive arrays programming, which are beneficial for performance optimization. And Zig's direct LLVM bitcode generation is a huge advantage for simplifying upgrades.
Interesting. So it's not just about speed, it's also about a better fit for the specific needs of the Rock compiler's architecture and workflow. It sounds like a strategic decision based on a careful evaluation of trade-offs.
Precisely. And let's not forget the goals for the rewrite. They aim to release this Zig-based compiler as Rock 0.1.0, the first numbered release. This means incorporating substantial language design changes, which makes a clean rewrite more efficient than trying to retrofit them into the existing codebase.
Right, a fresh start allows for a more streamlined implementation of these new features. It's a bold strategy, but it seems well justified given the circumstances. Plus to get. What about the challenges? Rewriting a compiler is inherently risky.
You're right, it's risky. But they're mitigating that risk by prioritizing reliability and correctness. They plan to incorporate fuzzing early in the development process, document as they go, and avoid potentially error-prone shortcuts like unwrap. They're also prioritizing code clarity and debuggability over short-term performance gains.
That's a smart approach. Focusing on a solid foundation first, then optimizing later, is often the best strategy for a large-scale project like this. It's exciting to see this project unfold. The potential benefits of faster compile times and a cleaner codebase are significant.
Indeed. It's a testament to the team's commitment to improving Rock and their willingness to embrace a significant challenge. This is a great example of how careful planning and a strategic approach can transform a seemingly daunting task into an exciting opportunity. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of compiler rewrites. Goodbye.
Bye-bye.